Hi everyone, this is Dr. V.S. Nishok from SNS College of Technology for the topic stick diagram from the subject VLSI design. So in our previous video, we have seen about the rules of stick diagram and importance of stick diagram and what are the color coding used for different MOS layers for representing in the stick diagram. As a continuation of it, here we are going to see the different examples based on the given stick diagram. So here we can see the slide mentioning stick diagram flow. So if you are going for any circuit design, we are starting with the Boolean function. For example, if you are taking an inverter, we are taking a inverter, CMOS inverter circuit, the Boolean function is represented as y equal to output y equal to inversion of input. So that is, we are taking input variable a, y will be equal to a bar. So that is the Boolean function. So it will be first represented in the static CMOS circuit and then it will be forming the stick diagram design. So this is the flow we need to follow for drawing the stick diagram. So to draw the CMOS circuit, we need the logic that how to represent the dot and plus terms of the Boolean function. For NMOS, we need to use the plus as parallel and dot represents the series connection. Similarly, for PMOS transistors, dot is parallel and plus represents the series connection. So mostly the PMOS transistor in the CMOS logic, the PMOS transistor will always be in the pull-up network and NMOS transistor will always be in the pull-down network. So based by using these two rules, we need to go for the design of CMOS circuits. So here we can see an example for stick diagram of NMOS inverter. Then we can go for the CMOS inverter. First we will see the NMOS inverter. For NMOS logic, the same flow should be followed. Instead of PMOS in the pull-up network, one depletion mode NMOS transistor should be used irrelevant of number of variables. So that means, so whatever may be the number of variables, the transistor available in the pull-up network will be only one depletion mode NMOS transistor. So coming to the next point, inverter Boolean function, that is output y equal to a bar. So from this we can draw the stick diagram. First we can start with the NMOS logic diagram and then we can go for the stick diagram. So here only one variable is used, so only one transistor is used in the pull down network as the NMOS transistor that is connected with the input. So in the pull up network, only one, since it is a NMOS logic, only one depletion mode NMOS transistor was used. Its terminal is connected with the source terminal. So that is, gate is connected with the source terminal as shown in the figure. So this is your example for NMOS logic for inverter circuit. So after drawing this one, for this circuit we are going to design the stick diagram. So coming to the NMOS transistor, in the stick diagram we need to cross the polysilicon with the N diffusion. So that is done in the pull down network. One polysilicon taken horizontal line and one green color represents the N diffusion. So since this is a NMOS logic, so for pull up and pull down network, common N layer, that is N diffusion layer, is taken. So here now pull down network is over. Similarly for pull up network, the depletion mode transistor is came along with the implant as shown here. Then the output is taken between the pull up and pull down network. So that represents the y equal to a bar. So for VDD and VSS, we are connecting the metals. For VDD and VSS, we are connecting the metals and giving the electrical contact between the N diffusion layer as shown here. So this is the way we need to design the inverter circuit using the stick diagram. So similarly we can see several examples. So stick diagram for NMOS NAND gate. So for NMOS NAND, what is the Boolean function? A dot B the whole bar. So that represents the Boolean function. So first we need to start with NMOS logic, then we go for the stick diagram. So A dot B. So as per the previous terms, dot in the pull down network represents, that is NMOS transistor represents the series connection of NMOS transistors. So A and B are connected with two different seriously connected NMOS transistors in the pull down network, and for NMOS logic the only one depletion mode transistor, NMOS transistor, is connected in the pull up network as shown in the figure. So in the similar manner we need to design the stick diagram for NMOS NAND gate as shown in the figure. So coming to the CMOS inverter, so here for CMOS logic, equal number of NMOS and PMOS should be used instead of depletion mode NMOS transistor. So for pull up network we need to go for PMOS transistor, and for pull down network we need to go for the NMOS transistor. So that is shown in the diagram here. So for the inverter, so y equal to A bar, so only one input is taken and given commonly to the pull up and pull down network. So the same thing is reflected in the stick diagram shown here. Polysilicon is connected with N diffusion and P diffusion in the pull up and pull down networks as shown in the diagram here. So additionally, since this is a CMOS network, we need to separate the pull up and pull down network with the demarcation line in the brown color represented horizontally shown here. So few examples based on CMOS logic. So we are taking the CMOS 2 input CMOS NOR gate. So NOR represents A plus B the whole bar. So first we start with the static CMOS circuit, then we will move towards the stick diagram shown here. So A plus B. So for NMOS transistor, A plus represents the parallel connection of two NMOS transistor with the input A and B. Similarly, for pull-up network, A plus, that plus represents the series connection of two PMOS transistor as shown in the circuit here. So after drawing this circuit, so in between the pull up and pull down network, we are taking the output and completing the circuit, and we are designing the stick diagram as shown here. So this is the way, based on the number of inputs, we are first from the starting from the Boolean expression, and we need to check whether it is CMOS logic or NMOS logic. Then we need to start drawing the circuit, and then finally we need to design the stick diagram with proper color codes that we have seen in the video. So this is the way we need to design the stick diagram using EDA tools. Most of the EDA tools use the same color code before designing the layout diagram. So once stick diagram is done, then we can move towards the layout diagram. So here there is another example with three variables. So f equal to output f equal to x dot y plus z the whole bar. So by using this example, here NMOS logic was done. So that is how we can see the NMOS logic means. So here if you see the pull up network, only one depletion mode NMOS transistor is there. So that it easily represents that it is a NMOS logic. So we are coming for the assessment part of this stick diagram video. So draw the stick diagram for 2 input CMOS NAND gate. So that is your first question, and tell me mostly followed color code of different layers, different MOS layers used in the design of stick diagram, and draw another stick diagram for NMOS 2 input NMOS NOR gate. So these are the 3 assessment questions based on this video. So here in our video we have started the stick diagram design from NMOS logic, and we have moved towards the CMOS logic, and we have seen the several examples, and we have seen the assessment, and then we are completing the video here. So these are the reference books where the stick diagram examples are available. We can practice for 3 input or some other input with different logics. Thank you. We can see in the next video.